Hello everyone, we are the students of Shivajirao Jondhle College of Pharmacy. Today we are going to study about mass spectroscopy. This presentation is prepared by Mansi Mhatre, Sayli Mundhe, Mahika Mukadam, Gaurav Naik, final year B Pharmacy students, under the guidance of Professor Manjusha Gite ma'am. Let's see about mass spectroscopy. Mass spectroscopy is one of the primary spectroscopic methods for molecular analysis available to organic chemists. It is microanalytical technique requiring only a few nanomoles of a sample to obtain characteristic information pertaining to the structure and molecular weight of analyte. It is not connect it is not concerned with non-destructive interaction between molecules and electromagnetic radiations. It involves the production and separation of ionized molecules and their ionic decomposition product. And finally, the measurement of relative abundance of different ions produced. It is thus the destructive technique in that sample is consumed during analysis. In most of the cases, the nascent molecular ion of the analyte produce fragment ions by cleavage of the bond and resulting in the fragmentation pattern constitutes the mass spectrum. Thus, the mass spectrum of each compound is unique and can be used as a chemical fingerprint to characterize the sample. Basics principle of mass spectroscopy. Mass spectroscopy is the most accurate method for determining the molecular mass of the compound and its elemental composition. In this technique, molecules are bombarded with a beam of energetic electrons. The molecules are ionized and broken up into many fragments, some of which are positive ions. Each kind of ion has a particular ratio of mass to charge, that is M to E ratio. For most ions, the charge is 1 and thus M-E ratio is simply the molecular mass of the ion. Analyte molecule can undergo electron ionization and the following equation is formed. This is the instrumentation of mass spectroscopy. As you can see, first is ionization occurs, then acceleration, then deflection and then detection. Let's see about this in next slide. Ionization. The atom is ionized by knocking one or more electrons off to give a positive ion. Mass spectrometers always work with positive ions. The particles in the samples are bombarded with a stream of electrons to knock one or more electrons out of the sample particles to make positive ions. Most of the positive ions formed will carry a charge of +1. Acceleration. The ions are accelerated so that they all have the same kinetic energy. The positive ions are repelled away from the positive ionization chamber and pass through three slits with voltage in the decreasing order. The middle slit carries some intermediate voltage and at the final at 0 volts. All the ions are accelerated into a finely focused beam. Deflection. The ions are then deflected by a magnetic field according to their masses. The lighter they are, the more they are deflected. The amount of deflection also depends on the number of positive charges on the ions. The more the ion is charged, the more it gets deflected. Different ions are deflected by a magnetic field by different amounts. The amount of deflection depends on the mass of the ion and the charge on the ion. In the mass of ion, lighter ions are deflected more than heavier ones, and charged ions with two positive charges are deflected more than one with only one positive charge. Detection. The beam of ions passing through the machine is detected electrically. When an ion hits the metal box, its charge is neutralized by an electron jumping from the metal onto the ion. That leaves the space amongst the electrons in the metal, and the electrons in the wire shuffle along to fill it. A flow of electrons in the wire which is deflected as an electric current which can be amplified and recorded. The more ions arriving, the greater the current. The next explanation will be given by Sayli Mundhe.
Ionization techniques. In a mass spectroscopy, there are mainly three types of ionization techniques, that is electron ionization, chemical ionization and desorption technique. First we will see about the electron ionization. Electron impact is the most common form of ionization. In this method, the high energy electrons are bombarded on the gas phase sample, that is a sample gas, and it forms the cation radical. In this method, very high energy electrons are bombarded on a sample gas, which result in the formation of cation radical. Then the ionization only requires 15 electron volt. Then the bond cleavage requires 3 to 10 electron volt energy of electrons. Then the primary weakness is the loss of the molecular ion peak. Here the diagram for the electron ionization is given. In this diagram we can see from the molecular peak the beam of an electron is passing and it is bombarded in this electron slit and anode, which result in the ionization of the gas phase, which forms the cation radical. Then the chemical ionization. The ionization of analyte is achieved by interaction of its molecule with the ions of a reagent gas in the chamber or any source. Then chemical ionization, it is a soft ionization technique. It leaves the molecular ion intact. Then the ionization occurs due to the collision of ionized gas with the targeted analyte. The ionized gas is collide with the targeted analyte. Due to this collision, the analyte it get ionized. Then desorption technique. It is also called as a fast atom bombardment method. It allows the analysis of a large molecule. Then the sample to be analyzed is dispersed in the matrix and placed in the path of the high energy neutral atoms. In this method, xenon and argon neutral atoms are used in this technique. Collision of a neutral atom takes place with the molecule of a sample to form iron and are forwarded to accelerating plates and finally to the mass analyzer. In this method, the uses neutral atom to ionize sample, which means both positive and negative ions are formed and it could be analyzed. Then these molecules basically includes polypeptide, nucleotide, oligonucleotides. Then the matrix used in this technique, it should be non-volatile and inert. Then we will see types of ions. There are several types of ions in a mass spectroscopy, that is molecular ion or parent ion, fragment ion, rearrangement ions, multiple charge ion, negative ion, metastable ion. We will see firstly molecular ion, also called as a parent ion. When a molecule is bombarded with electrons in a high vacuum in a mass spectrometer, it converted into positive ion by loss of an electron. These ions are called as a molecular or parent ions. As the reaction is given here, the molecule plus the electron, that is electrons which are bombarded on the molecule, it forms the molecular ion, that is positively charged, and the loss of an electron, that is 2e minus. The order of energy is given below for the removal of electrons. Many of these molecular ions disintegrated at 10 raised to minus 10 to 10 raised to minus 13 seconds to give the positively charged fragment and the radical in the simplest case. If some molecular ions remain intact long enough, to reach the detector. To reach the detector, the time limit is 10 raised to minus 6 seconds. Most molecules shows the peak for a molecular ion, the stability of which is usually aromatics are the most stable. After the aromatics conjugated or cyclic polines, then alicyclics, N-hydrocarbons, ketones, ether, branch chain hydrocarbons, and lastly the alcohols. In this, aromatics are the most stable one. Characteristics of molecular ion. Molecular peak is observed if a molecular ion remains intact long enough to reach the detector. So, to reach the detector, the molecular ion must be intact up till 10 raised to minus 6 seconds. This peak gives the molecular weight of the compound. The molecular ion peak is usually the peak of the highest mass number. The mass is the mass of the molecule. Molecular ion is the most important parameter because the molecular ion has the mass which is corresponding to the molecular weight of the compound from which it is generated. So therefore the mass is the most important parameter. Then the significance of a molecular ion. Molecular ion peak, it gives the molecular weight of the compound as we seen in a characteristics, that is m by z of a molecular ion is almost equals to the weight of the compound. The example is given here, that is ethane.
There are many types of ions, so one of which is the fragment ion. When the energy is given to a molecular ion during the electron impact, further cleavage takes place and the ions of lower mass number known as fragment ions are produced. So M plus gives us M1 plus M2. So example is CH3OH plus gives us CH2OH. Here the mass to the charge ratio is 32, which is reduced to 31. Now, the rearrangement ions. So, rearrangement ions are the fragments whose origin cannot be described by simple cleavage of bonds in the parent ion, but are the result of intramolecular atomic rearrangement during the fragmentation. So, these are probably due to the recombination of fragment ions and are known as the rearrangement peaks. So, example is prominent peak in the spectrum of diethyl ether occurs at the mass to the charge ratio of 31. So what is this is due to the ions that are CH3O plus and which are formed by the rearrangement of C2H5OH plus ions. Now, multi-charged ions. Sometimes ions may also exist with two or three charges instead of usual single charge in the mass spectrum. So these are known as doubly or triply charged ions. So these are created as follows. That is M plus E minus gives us M plus 3 electron minus. But under the normal operating condition, most of the ions produced are single charged. But the double and triple charged ions are recorded at half or one third of the mass to the charge value of the single charge ions. So formation of this multi-charged ions is more common in heteroaromatic compounds. So these are also known as or common in the inorganic mass spectrum. So gases such as CO, N2, CO2 and O2 have measurable peaks corresponding to CO plus 2, N plus 2 and O plus 2. Now what are the negative ions? So positive ions predominate in the electronic impact ionization because of greater stability. So the negative ions are not useful in the structural determination. So the formation of negative ions is very rare, but they are produced, and the AB plus electron gives us A plus B minus. Now metastable ions. So fragment ion of a parent ion fragment of a parent ion will give rise to a new ion I plus either a neutral molecule or a radical. So M1 plus gives us M2 plus non-charged particle. Now an intermediate situation is possible. So M1 plus may decompose to M2 plus while being accelerated. So the resultant daughter ion, that is M2 plus, will not be recorded either at M1 or M2 but at the position M plus as a rather broad poorly focused peak. Such an ion is called as a metastable ion. Now what is the nature of metastable ion? So metastable ion have lower kinetic energy than the normal ions, and metastable peaks are smaller than the M1 and M2 peaks and are also broader. So this metastable ion arises from the fragmentation that take place during the flight down through an ion rather than in the ionization chamber. So type of mass analyzer. So there are three types: magnetic sector mass analyzer, double focusing mass analyzer, quadrupole mass analyzer. Now what is a magnetic sector mass analyzer? So magnetic sector mass analyzer consists of two, that is single focusing and double focusing. In single focusing, a magnetic field is used to focus ion based on their momentum as they are ejected from an ion source at a high energy. So the resolution is greater than the 2000. And double focusing now. So an electrostatic analyzer is used serially with the magnet to select a monoenergetic ion, so high resolution, that is lower than the 10,000 mass up to the 1 lakh Dalton. Now what is the procedure? So here the mass analyzer uses the magnetic field to separate the ions of different mass to the charge values. So high voltage is first applied to the ion to accelerate them in the magnetic sector. Now a continuous ion source is generated and supplied from the ionization until the magnetic sector. So once the ion enters the exposed magnetic field, as a result, the ions are deflected according to the Fleming's left hand rule. So the deflection differ based on their mass to the charge ratio, where lighter ions will experience more deflection. Now what is double focusing type? So for many application, much high resolution is needed and achieved by the modification. So an electric field region is present before or after the magnetic field region. So in presence of electric field, all particles travel at the same velocity and resolution of mass analyzer, so which improves a factor of 10 or more over the magnetic sector alone. Now what is quadrupole analyzer? So this quadrupole analyzer, it has four rods that are the electrodes with the electric field around them. So electrodes have both DC and AC, that is RF, and voltage is applied to them. So each pair of the rod have exactly the same voltage as the one directly opposite. So depending upon the affected by the magnetic field. Here the DC bias will cause all the charged molecules to accelerate and move from the center line. The rate being proportional to the charge to the mass ratio. If their course goes off too far, they will hit the metal rod or the sides of the container and be absorbed. So the DC bias acts like the magnetic field B of the mass spectrum and can be tuned to the specific charge to the mass ratio hitting the detector.
Fragmentation rules. So basically there are three rules. First rule is the relative height of the molecular ion peak is greatest for the straight chain compound and decreases as the degree of branching increases. Second rule is the relative height of the molecular ion peak usually decreases with increasing molecular weight in a homologous series. Third rule is cleavage is favored at alkyl substituted carbon atoms. The more substituted, the more likely is the cleavage. This is the consequence of the increased stability of a tertiary carbon atom over a secondary, which in turn is more stable than a primary. Factors influencing fragmentation process. First factor is bombardment energies, second is functional groups, and third is thermal decomposition. General modes of fragmentation. There are two modes. First one is simple cleavage and second one is rearrangement reactions accompanied by transfer of atoms. Simple cleavage occurs when the radical and odd electron from the bonds adjacent to the radical migrate to form a bond between the alpha carbon and either the heteroatom or the unsaturated functional group. Simple cleavage involves homolytic cleavage, heterolytic cleavage, and retrodiol-Alder reaction. Homolytic cleavage. In homolytic cleavage, the electrons are equally transferred to both atoms and it forms radical. Heterolytic cleavage. In this type of cleavage, both the electrons of the bond are taken over by one of the atom. The fragments are an even electron cation and a radical with the positive charge residing on the alkyl group. Retrodiol-Alder reaction. It includes elimination by multiple O bond, in which the cyclohexene is broken down to diene and dienophile. It can be explained by one or two electron mechanism. Here is a reaction in which the cyclohexene is broken into diene and dienophile. Here we complete simple cleavage. Now the second type, rearrangement reaction accompanied by transfer of atoms. First one is scrambling. Fragmentation giving rise to the stable carbocation. In certain cases, fragmentation takes place at bond and gives stable carbocation. Second is McLafferty arrangement. Tropylium ion fragmentation due to rearrangement of molecular or parent ion. Here, cleavage of bonds in molecular ion is due to the intramolecular atomic rearrangement. This leads to the fragmentation whose origin cannot be described by simple cleavage of bonds fragmentation. Third one is elimination. Fragmentation due to loss of small molecule, that is loss of small stable molecules such as H2O, CO2, CO, CH from molecular ion during fragmentation. Example, an alcohol readily loses water molecule and shows a peak 18 mass units less than the peak of molecular ion. Applications of mass spectrometry. Mass spectrometry has both qualitative and quantitative uses. Structure elucidation, detection of impurities, quantitative analysis, drug metabolism studies, clinical, toxicological and forensic applications are some applications of mass spectrometry. We are thankful to our President, Honorable Dr. Shivajirao Jondhle Sir, Secretary, Honorable Dr. Geeta Khare Ma'am, and our Principal, Dr. Nitin Moire Sir, for encouragement and guidance for efficient use of social media to spread knowledge through making informative videos. Hope you like this video. Please like and subscribe our channel for more informative videos. Thank you.